Hello, this is question 11 on your paper 1 from AQA in June 2022. So you have a polynomial is given by this expression here, and b is a constant, so this b here and here. Use the factor theorem to prove that x plus 2 is a factor for all values of b. So this is quite simple. Remember, if the factor theorem tells you that if x plus 2 is a factor, f minus 2 must be 0. So that's what, or in this case is p, sorry, p minus 2. So what we are going to do is to substitute minus 2 in the function. So p minus 2 of minus 2 is minus 2 cubed plus b plus 2 times minus 2 squared plus 2 times b plus 2 times minus 2 plus 8. So we have minus 8 and plus 8 here, that they are just going to go. And then I have 4b plus 2, so plus 4b plus 2. And here I have minus 2 times 2 minus 2, multiplying the b plus 2. Yeah, so this minus 8 goes with this plus 8, and this, sorry, I say 4 and I wrote 2, so this is 4 minus 4. And then this 4b plus 2 is going to go with the minus 4b plus 2. So this is 0 in total. Yeah? So therefore this function is 0 for any value of b because they are just cancelled. Then the graph of y equals p of x meets the x-axis at exactly 2 points. Sketch a possible graph of y equals px. So we know that one factor is x plus 2, which means one root is the minus 2, is in the minus 2. So we know the graph is going to cut here in the minus 2. Another option, if it cuts in 2 points, that means that the root is going to be double, but we don't know exactly where it is. So let's say it's something like this. Yeah, where this root is double, but we don't know where it is. And then we are able to write the y-intercept. So if you are able, you should write it down. The y-intercept is going to be 8. Yeah, so when x is 0, all is 0, except the 8. So this is my y-intercept, and you should write it. And you don't know this value, and that's okay. Yeah, because this is one possible graph. They are not asking you any particular. And the other thing is that x cubed, the coefficient is 1, so that's why my graph goes up and not down. Yeah, so this is one possibility. This value could be here, this could be anywhere. Then, given that px can be written in this way, find the value of b. So we're going to use the fact that this has the x-axis 2 points, so which means it has two solutions, right? One comes from here, the other must be double and comes from here. So this quadratic must have only one real solution, which means the discriminant is going to be 0. So the discriminant of this quadratic is going to be b squared minus 4 times 1 and times 4, yeah, so minus 4 times 4, and this must be equal to 0, which means that b is going to be 16, sorry, b squared is going to be 16, which means that b can be 4 or minus 4. If b is 4, this quadratic would be x squared plus 4x plus 4. When we factorize, we will have x plus 2 squared. And if e is minus 4, we will have this thing here. So the same, but with a minus, which means that will be x minus 2 squared. If this is the case, the whole px would be x plus 2 squared. So the whole thing, px, could be x plus 2 cubed. Yeah, and then the graph would only meet the x-axis in 1 point. Yeah, it would do something like this, remember? But it says that cuts in 2 points. So this case cannot be, yeah? So b cannot be 4. And in this case, px would be x minus 2 squared and then x plus 2. And here we will have two roots. One will be this one, the minus 2, and this one would be positive 2. Yeah? And that would be the case. So b has to be the minus 4. Just because of that, because if it's 4, and you should write a line saying, because if it's 4, if b is 4, I will have only one point of intersection, yeah? One point of intersection with the x-axis. With x-axis instead of 2. And that's all. Yeah, that's all with this question.